Let us start with the first unit, the information processing model. As we explored in the previous module, we discussed the advent of the cognitive perspective in the study of learning and instruction, and during the 60s, when the computer model became more and more important as a sort of metaphor which stimulated learning theorists, learning psychologists to develop theories about human learning. This computer model, this computer metaphor, is definitely the source of inspiration for the multi-store model, which was developed by Atkinson and Shiffrin in 1968. Basically, it's a three-store model. We're going to explore the model now in some detail. We have three stores here, each with its own characteristics: the sensory memory, the short-term memory, and the long-term memory. Now let's first explore the system and then the processes which are also mentioned here in this picture: attention, rehearsal, encoding, and retrieval. But first, the three stores, the system as such. The three stores are the three stages in which human information is being processed are the sensory memory with its abbreviation, short-term memory, STM, and long-term memory, LTM. The idea is basically that information is entering the system through the senses, so through the eye, through the ear, and the other senses. So the incoming information arrives at the first stage, or the first platform, or the first store, which is called a sensory memory. And this sensory memory is basically specific for each of the senses. So we have something like a sensory memory close to the eye and close to the ear, etc., etc. A typical example of the sensory memory close to the eye is what we call the after image. If you focus on something like a red dot on a white background for, let's say, 1 minute, keeping your head as stable as possible, and then when you close your eyes, you will probably see a green after image, which is the sort of complement of the red dot you saw and you were concentrating on. Now, this green after image is a sort of sign that there exists some sort of representation close to the eye, which is kept there for a very, very short period of time. There's a rapid decay in the order of milliseconds, and the information is completely lost unless you pay attention to the information, and through the process of attention you bring the information from the sensory memory to the short-term memory. And the short-term memory is the second stage or store or platform, or however you want to call it. And this short-term memory is basically the place where the work is being done, where information is being used and reused and integrated with existing information. That is the reason why many learning theorists prefer to call the short-term memory the working memory. So the working memory is the place in memory where the work is being done, basically, where information is being processed and where problems are solved and answers are given and prepared, etc., etc. Everything is done in working memory. Now, again, working memory has a very limited capacity, albeit a bit larger than the sensory memory, and the information stays in short-term memory again for a short period of time, but now we are talking about seconds and not about milliseconds. So in that sense, short-term memory does resemble the sensory memory because the information is quickly lost. And you have to do something to keep it into short-term memory. You can rehearse, you can just repeat the information in short-term memory in order to keep it there, maintenance rehearsal as it is called. And when you do that, then you keep the information in short-term memory. To give an example, imagine, but it's a bit old-fashioned example, but imagine that you have to call a person by telephone, and the telephone is a landline somewhere in a cafe or whatever you are, and you have to find the number of the person you have to call in the telephone directory. This is an old-fashioned situation, but again, let's explore it for the sake of the example. Let's say that the telephone directory is on the bar. There you find the number of the person you want to call. It's a string of 10 digits, something like that. And the telephone is somewhere else, in a small place where it is quiet. Now, in order to be able to dial the number, you have to repeat it whilst you're walking from the bar to the telephone. And in repeating, you keep the 10 digits in short-term memory, and then you were able to use them to actually dial the number you have to dial. But when somebody stops you in that process, meets you, sees your face, say, hey, hello, nice you are here, then all of a sudden the number is lost. So you have to, this maintenance rehearsal process needs a lot of attention, is a very effortful process, and you have to constantly keep your attention focused on the rehearsing in order to be able to reproduce the number when you have arrived at the telephone. Now, that's an example of maintenance rehearsal as it is done in order to keep information in short-term memory. But of course, you can bring the information also to long-term memory in a process that's called encoding. So you basically try to integrate the new information which comes from short-term memory into long-term memory. And long-term memory as such has an unlimited capacity. That's a very reassuring idea, I think, that everything you want to store there can be stored. There's room enough for everything. So, but the problem is not so much the storage, the encoding, but to find the information in long-term memory through the process which is called retrieval. So finding something back in memory. That's far more difficult than bring it into memory. But these are the three stages, the three platforms, the three stores, as you'd like to call it. And the end station is basically long-term memory. So the information enters the system through the senses, through sensory memory. Then it's by paying attention to it is brought to short-term memory, and then by the process of encoding, it's transferred into long-term memory, and there it stays and can be used for future purposes. Okay, so that's the basic original idea by Atkinson and Shiffrin. There are all kinds of, refinements and elaborations on this model, but let's keep it a bit simple and just keep it like that. But now we will go into the processes a little bit more detail. Attention, rehearsal, encoding, and retrieval. Attention is the process which transfers information from short-term memory to long-term memory. Attention can be studied in all kinds of, situations. You can consider the focused attention on a particular situation, or the sustained attention. For instance, when you drive a car and you have to stay focused for a longer period of time, let's say an hour or something like that. And then you can also study, of course, whether people are able to focus their attention to the road and the traffic and everything they have to attend to. The interesting thing is that you not not always very much aware of what attention is, and in order to let's say discover that, you might have a look at the short YouTube video, which I'm going to start now.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Chabris and is copyrighted. It is available for use in talks, training, and teaching on DVDs from VisCog Productions. Learn more at theinvisiblegorilla.com.
Okay, an interesting example of selective attention, which makes you aware of the fact that attention is always present and directing the information intake. So not everything you see or what's impressed on your ear or eye or whatever sense you're talking about is transferred to short-term memory, is being used. A lot of the information is rapidly decaying. And that's, I think, a blessing, because otherwise you might become completely crazy by all the impressions you got when you just are bombarded, with all kinds of stimuli from every side. So selective attention is a very important mechanism in order to focus and in order to bring the necessary information from the sensory memories to the short-term memory in order to process it further and use it in whatever cognitive process you are involved in. So that is an example of attention. Attention, of course, is a very broad subject which has been studied by many learning and psychologists and psychologists focusing on perception and attention as such. Okay, the second process is rehearsal, keeping information in short-term memory. I already gave you an example of maintenance rehearsal in which you try to keep some information, let's say a telephone number, in your short-term memory. Encoding is the third process we're talking about, and this is the process by which information is brought from short-term memory to long-term memory. This is a very important process, and again, a lot of effort is involved here in order to let's say reduce the load, the cognitive load, which brings this process of transfer about. And the interesting thing is that people are able to reduce the size of information. I did not mention the paper by George Miller, a very famous paper written in 1956, which is called The Magical Number 7 plus or minus 2. This paper actually focuses on the size of the information which is kept into short-term memory, or the size of short-term memory itself. How many units of information can short-term memory contain before it's completely filled? And Miller's idea was that it is something like 7 digits or 7 independent units, letters or pieces of information or whatever. More than 7, or at least more than 7 plus 2, 9, is impossible to keep in memory by the process of maintenance rehearsal. But soon people discovered that this is not a complete story. Let's see. Let's have a look at this particular list of digits. 1, 4, 9, 1, 6, 2, 5, 3, 6, 4, 9. Imagine that you have to learn these digits by heart and that you have to reproduce them, let's say, after a couple of minutes. 1, 4, 9, 1, 6, 2, 5, 3, 6, 4, 9. It might be quite a cumbersome task to learn this by heart. But when I tell you that this list of digits is organized in a particular way, it becomes a lot easier to remember it. These are all quadrats. You know, the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, the square of 4 is 16, the square of 5 is 25, the square of 6 is 36, and the square of 7 is 49. So we have squares here. And we just have to keep in mind that there are 7 squares here in a sequence of digits. Now, if you discover that rule or that pattern behind the sequence of digits, then it becomes a lot easier to remember this list of digits. And it might be a very easy task, in fact. Well, this is an interesting thing that people make chunks of information, you know. So the chunks are here 1, 4, 9, 16, 25, 36, and 49. And these chunks have a lot of characteristics in common. They're all squares. Squares of the first 7 natural numbers. So we have an organization. We have which makes it easy to reproduce it. Now, that kind of organizing information is what people do, constantly do. And that makes it a lot easier to encode information, bringing it from short-term memory to long-term memory. Retrieval is the process by which you try to find information in long-term memory. And that is a very cumbersome task, as you all know perhaps, or have had the experience to learn. When you had to reproduce knowledge during an exam and just were you know digging into your memory to find some particular piece of information. Okay, so the retrieval process is a very important process and is a very vulnerable process also. You can imagine that during a lifetime, when people get older, this retrieval process becomes more and more cumbersome. For instance, finding names of people. When you have a very vivid image of the face of a particular person, but you simply cannot find the name of a famous, you know, actor or a pop star or whatever. So the retrieval processes are vulnerable also when people get older and older. And yeah, well, the way it is organized during the process of encoding, of course, determines also the way information is being retrieved. There is a particular phenomenon which is called state-dependent memory. State-dependent memory, which, let's say, refers to the fact that when you encode a particular piece of information, you also encode a lot of information which is, let's say, available at the time of encoding and at the place of encoding. So you not only encode the particular item you have to learn by heart, but you also encode the environment, the atmosphere, the temperature, your feelings, perhaps. These are all taken also into the code, and they are also ways to find the information. They are also pathways into the retrieval process. There's a very famous experiment in which 2 groups of students learned a list of let's say, words by heart. The first group of students was working on this learning task in a normal classroom, and the second group of students was taken to the local swimming pool, and they learned the list at the bottom of the swimming pool. A bit of organization you can imagine. But anyway, they were there at this particular swimming pool, and there they learned these words. Now, both groups were split into half. One half, during the retrieval, so the test, the retrieval task, you know, when they had to reproduce all these words they had learned, one half was taken to the place where the information originally had been acquired. So in the classroom, for instance, or at the bottom of the swimming pool. And the other half of the participants was taken to the other location. So the students who had been working on the task in the classroom were taken to the swimming pool, and they had to reproduce the words at the bottom of the swimming pool. And the students who had been acquiring the words at the bottom of the swimming pool, they went to the classroom, and there they did the retrieval task. Now, you can imagine that the test performance of these four groups was completely different. So the groups who were tested in the same location as where they had learned the words, they outperformed the two groups of participants who were taken to the other location in order to reproduce the words they had learned. Now, this just is an example of the state-dependent memory phenomenon, because the states were different for these last two groups, and therefore their performance deteriorated. So they could not make use of all these cues, which were not in the words but in the environment, when they had to do the retrieval task. So that's an example of what is called state-dependent memory, and it is definitely a very influential factor during retrieval processes. Okay, let's see. We've now explored the information processing model in some detail, and I hope you can use that information whenever you have to do some research in the domain of learning and instruction.